Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am your host, Dean Phillips. I want to thank our sponsors, the Precision Metal Forming Association and the PMA's Educational Foundation, for helping us put this show on. I have a really unique opportunity today. I'm interviewing Dean Phillips from Link Systems. Dean. Hey, it's great to be here. Thank you so much. This is a really different conversation that I've never tried to have before, but let's give it a try and see how it goes. I like your spirit. Well, of course, we're coming up to the Internet of Things conference in June for the Precision Metal Forming Association. And as the sales engineer for Link Systems, what can you tell us about the future of manufacturing, the destiny of manufacturing, if you will? So 5 years down the road, what are we looking at? Well, that's a complicated question. There's a lot of things that are going to be changing over the next 5 years, but I think the most exciting part of it is the embracing of the technology itself. It's something we haven't seen before. For a long time, we've been gathering data. We've been gathering information for years. And for the first time, we see that manufacturers are starting to embrace this technology, embrace the information, and understand the true value of where this is going to take us. So I believe it's a really exciting time, and it's something that we're going to see a lot more of over the next 5 years. So how did you come to be involved with the Internet of Things and specifically Link Systems? Well, I started off in technology years ago. I was the, if you want, technology person for the engineering staff at Niagara. I was the service tech that went out on the more high-tech machines, on the press brakes, and on anything that had a control. And it was my responsibility to go out and do the field service work on that type of equipment. After 10 years being involved with that side of the business, it gave me a really unique insight into what people were looking for information. It's amazing that if you go back 30 years ago, fabrication was so willing to embrace technology, but on the metal forming side, we were really very slow to the party. Why do you think that happened that way? What was it resistance? Was it a lack of understanding? No, I don't think it was a lack of understanding or a lack of willingness to embrace the technology. The problem was, I think, because you're talking about metal forming and you're talking about stamping, it's a slow evolving industry because it takes a while to hard tool and to make that movement to that, as opposed to fabrication, which is all geared around rapid. And for that reason, those technologies have evolved much quicker. And you even see that even today of organizations that produce laser technology. That technology turns over so much faster because of a willingness to embrace that technology and the importance of staying state-of-the-art, so to speak, in those industries. Whereas the stamping industry, it's been the attitude of it's just a big hammer, and it's taken us a long time to really understand that it's more than that. It's more creative than that. What other things do you see on the Internet of Things changing, and what do you see that having an impact on over the next 5 years? Well, that's a whole different can of worms. The technology itself of IoT and the philosophy has been around for quite a while. I mean, I've been with Link Systems now coming up on 14 years, and in those 14 years, we've always had LinkNet, which allows the machines to talk to our computers and give us information and gather information and report on what's going on the shop floor. But it's been slow to get embraced both on the floor side and in the administrative side to where we are today. I think it's amazing. Over the last couple of years, that side of it has really taken on its own personality, and people have been willing to take over that technology and willing to take ownership of it, possibly driven more so even by ERP systems, which have relied so much on manual inputs. So you're talking about companies like Plex and SAP. Those types of systems have been driving more of the technology. In many ways, they are, because people want and see that there's information on the shop floor, and it's now that people are saying, well, why can't this system talk to this system? Why are we having to manually input this? Why am I having to tell you how many parts I'm producing? Why can't this system talk to this? And that's really where we're seeing more of the Internet of Things coming from, the sensor side. Why can't these sensors communicate back to my computer? Why can't I look on my tablet and get real-time information? What has driven this from a cost side? Well, that's a huge different thing, because one very important aspect you see today is the cost has come down on so much of the technology. Sensors are so much cheaper. You see, let's look at drone technology. You can pick up a drone for $100. You can get 3D printers for a couple $100. Technology has reached a pinnacle as far as cost effectiveness. We can get more technology. Arduino and Raspberry Pi systems you can pick up very cheap and develop a lot of technology through those. And even in our systems, the reporting side hasn't gone up in price, and in many cases the cost of the technology has gone down on the reporting side on the actual equipment. I think what we talk about, and I've used the phrase loopy technology, is where people have kind of had a shift in understanding. What does that mean, loopy technology? Well, for a very long time, we've always had these loops. A press control or any piece of equipment that's variable speed has had a variable speed drive and a feedback loop to tell it how fast it's going, so that you don't have to go in and say, oh, it's too low, it's too fast, go in and make this adjustment. It does it without you even being involved. And that's been a very small loop that happens between the device and the control. Then what you see now is even the sensor side, which was reporting just to the control itself to tell you the feed has fed into position or the slug did not come out of the die. Those types of things were only seen on a local level. Now people are able to see them on a larger level through things like LinkNet and other types of reporting software on a broader scale. So now you know the machine's running. You can go and look at, from a very broad view, what's going on your plant floor. Are you producing parts the way you think that you should? Are the tonnages that you're expecting to be hitting, are they hitting that? Where are we on material side? And that's an important aspect of being able to see onto the floor, know what's going on. And for a long time, we've kind of relied more on the shop floor to tell us what they think they need or to tell us what's important. And without really knowing what was important to them. and the value and payback of those things. Now, we're able to monitor and feed back that loop of information back to a computer and saying, here's the report for this machine, here's the report for this machine. This one's more productive because it has hydraulic clamping. This one has rolling bolsters. So the changeovers are much quicker. That information then can be processed and said, here's the comparison between these two, and here's the value added of this technology, which then allows people to make a better, more educated decision on allocation for personnel, money. It helps them to see what is important to them on the shop floor when it really comes down to dollars and cents, the value of that person, that value of that machine, the value of the product you're producing. You can put all of that into a larger scale format now, not just go out on the floor and say, hey, is that machine running or not running? That information, while being of value to know the machine's running, it's more important to know why it's not running. If it's not running because it wasn't supposed to run. It's not running because we don't have material. It's not running because the feed's not working. It's not running because of ... That information lends itself to making better business decisions. And that's really driven a lot of this, is this information. What has prevented this from occurring earlier? What has changed recently? Well, I think a lot of it is just people. I hate to say this, but the wow factor of Internet 4.0, the IoT phrasing, and it being everywhere and bombarding people with those terms, to where it's FOMO, fear of missing out, and I think that's where we are. So you think that more people are worried about missing out than what it's providing? Well, in some cases, yes. In some cases, they don't want to miss the boat. They don't want to know that their competitor down the street is using this technology, and every day they're getting better and you're falling further behind. So it is driving it, even though it is somewhat tied to technology. Why does everybody need to run out and get the latest Apple phone? Is it really that much better technology, or is it the fear of missing out? And there's an element of that we see in our technology and in metal forming that's creating this buzz and stir, but it's in a good way, because it's driving people to make improvements that they've not made for years. There's a lot of people now that are seeing the light, and they're seeing the value and the payback, and they're saying, man, we should have done this years ago, or we really should have been acting on this information. We've known this information for so long. Why have we not been doing this earlier? And that's part of it, and it ties back into Lean and Six Sigma and those systems, and helps them make better decisions on, first of all, where are our holes in the Lean system? Where's our low-hanging fruit? On the Six Sigma side, are we being consistent? And when we're making improvements, are they consistent? Are they going to be there forever? Are we making something that's stable and is going to continue? And those types of decisions that they're going to make based on that are really improved through information. Information technology has taken a huge turn in the availability of it, and not just availability that it's there, it's availability in your device. You can go on a website right now and you can look at your plant, their production, what their reports are for downtimes. You can look at all of that online through systems like LinkNet and other ones that are out there. What going back to the loopy technology, what does that provide from a higher level of information?
Well, from a higher level, you're gathering not just the information that you would have from the individual machine, but you're able to make comparisons against your entire shop. You're able to see where the bottlenecks are and what's preventing you from being as productive as you should be. It's also showing you tools that maybe this tool runs real well in this machine. It doesn't run real well over here. So that's incredibly important to manufacturers and stampers. It's also telling you, here's how much tonnage I had when I started. Here's the timing diagram that I had when I was hitting this tool before. We sent it out to be sharpened or to be reworked. And now the timing is different. So now you can compare your tonnage graphs. You can look at things like why you've been down, like things like we've had errors because of, let's say, the brake monitor hasn't been reporting very well. Not that the brake monitor's not reporting well, but that machine and its brake itself or clutch or whatever the cause that's generating a bad stopping time. Sometimes it's air pressure, sometimes it's other things. But it helps you narrow down and drill down to the root cause of your problems from a maintenance standpoint, from a production standpoint, and from all of the greater ideas that are going on in your shop that you just rely on people to interpret this information. Because for a long time, we're just using interpretation of what we think is going on. When you can tap into that and put numbers along with it, that makes a huge difference. I know a plant that prior to LinkNet had a problem with loading tools, and it would be that they couldn't load a machine because they had only so much aisle width, and they couldn't load the tool on the one machine because the other one had to be shut down while the fork truck was driving in that area. Well, they've known that for years. They knew that that was a problem, and everybody said that that was a problem, but they didn't want to fix it until LinkNet told them, here's how much money you're losing because of this. Not just on the machine that's down for a tooling changeover, but here's the money you're losing on this other machine because of this same changeover that has nothing to do with it. That type of information is invaluable. I've been to plants down in Texas before, and they were really efficient with their fork trucks. They would take the tool out, they wouldn't put it down, take it right to the rack, put it away, get the next tool, pick it up, put it in the machine. Well, yeah, picked it up once and picked up the next tool and picked that one up once. Well, the problem was the machine wasn't running during that time. So you're looking at the wrong things to be efficient at. And that's where this type of information can help improve what you're doing. And the IoT conference coming up here in June, a lot of the people that are going to be there are going to have a lot of great information to help you be more productive and take these ideas back to your shop and be able to improve. And that's what the IoT really is about, is gathering information, making you better, making your people better, and in the greater scheme of things, making you more profitable.
That's an amazing change in where we've been. What are some of the things that we can expect to see in the other technologies over the next few years?
Well, they're happening today. The information that's happening and being gathered now, these sensors are getting better. They're getting more sophisticated. When you plug in a new sensor, it's able to automatically populate the data when it's plugged in that it had before, the reference information, so that calibration is quicker, calibration is more accurate, and you have less setup time, less less problems with putting in maintenance. You even see things in VR and augmented reality that's able to set up and speed up the way that we do things. I've seen some technology out there on that side of it where they're developing, let's say, a rack system for stacking parts. Well, through the use of virtual reality, they were able to determine that handling these parts the way they thought they were going to be able to produce these racks was not going to be efficient. It wasn't going to be effective. They weren't going to be able to stack as many as they thought. And through that, they were able to fine-tune this changeover so that when they made this line shift, that they were able to already know the problems and address them before it ever happened, before they went through the trouble setting this up, putting this on their plant floor, and knowing it. The other things you see out there now is through things like, not specifically Google Glass, but that type of system that people are familiar with. They can go out and through augmented reality, they can actually see, and a technician can see what the other person's seeing. They can look through their eyes and say, no, don't put your hand on that one. That's not the valve I'm talking about. Look to the right. That's the valve you need to adjust. And they can help technicians that are on plant floors work through problems easier, simpler, and be more efficient with their time rather than, hey, go and check this voltage, come back and tell me what it is. Now I can see what that voltage is while you're doing it, especially for things that are intermittent or take a long time to troubleshoot. You can cut down on your troubleshooting time by hours. And that's a huge difference when you're talking about thousands of dollars you're losing per minute, not per hour. That's a huge difference.
Is all of this technology available now?
Well, most of the technology is available now. I think implementation is going to take some time. Some of this is going to take some time to move down that road. Using 3D printers, for example, the materials that we're using are improving all the time. The way that we use some of these are every single day, these 3D printers are developing new materials, are able to print materials we never thought we'd be able to do, making these materials stronger, making them more durable, making them able to work in conditions we didn't think was possible even 5-10 years ago. So even in rapid technology, we're seeing changes on the tooling side, on developing materials, building parts that we never thought we'd be able to. I can see a time in the future where you need a new part. Rather than go and try and order it, get it delivered in months, you'll be able to download a file and print a new one. It'll be the new version of an iron worker will be a 3D printer in every maintenance shop.
That's an amazing shift in technology from where we are today and where we're going. Well, Dean, I really do appreciate you taking time to be here today. It's been fantastic. I want to thank all of our audience, thank the Precision Metal Forming Association for taking their time and being willing to support this show, both in time and in effort. And we really do appreciate the Precision Metal Forming Association and the PMA's Educational Foundation for this. I really want to thank them and thank Brad Cooven over there for all of his support on this podcast. Thank you, everybody. Have a great day.